All right, this is the second page, and we start off with a really interesting but a little difficult problem here. So we have a triangle. So I'm going to draw a triangle. And it says that the base of the triangle is 3 centimeters longer than 2 times its height. So if this is height, then this is going to be 2h minus 3. And we know the area of a triangle is base times height divided by 2. So we have h times 2h minus 3 divided by 2, and this all equals 115. This is already looking like a nasty problem, but let's solve for h. We need to get the h. So let's multiply everything by 2. So we get h times 2h minus 3 is equal to 230. And already I can see this is turning into a quadratic problem, because when I distribute, I get 2h squared minus 3h is equal to 230. Well, I have an h squared, which means I have a quadratic problem. And in a quadratic problem, a couple things have to be true in order for me to solve it. First, it has to be equal to 0, and it has to be in factored form. All right, so minus 230, minus 230. Now I can't combine that with anything else, so I get 2h squared minus 3h minus 230 is equal to 0. And so now I need to factor that. And so I'm going to look at these two, and this is going to be tough, folks, and I will explain what I'm doing. I'll try to explain what I'm doing. So the way I like to think about this is, so I break this into factors. So we have 2 and 1. And I want to break this into factors also. And obviously negative 235 is going to have a lot of different factors, but I need to think of things that are fairly easy to come up with, since this is a written round problem. And so I'm going to go with 10 and 23. I understand one of them has to be negative in this case, but just bear with me for a second. And so due to factored form, I'm going to be multiplying one of these numbers times one of these, and then the other number gets multiplied by the other one also. And then because this is negative and because this is negative, I'm going to be subtracting them, and so the products of my two multiplication problems has to have a difference of 3. That's what I'm thinking of. And so right now I see 2 times 10 is 20. 1 times 23 is 23. That has a difference of 3. That means that the 2 and the 10 have to be in different parentheses. Obviously h times h is h squared. I don't have to write the 1. And then that means the 1 and the 23 have to be in different parentheses as well. Here's the 23, here's my 1. And since this is negative, and I'm multiplying to get the 23 here, that has to be negative and this has to be positive, and this is all equal to 0. So now I have successfully factored this. If you need help factoring, which you probably do, please let me help you on that one. So then I need to break this apart and set each side equal to 0. Because in other words, I have two numbers multiplied together and I'm getting a product of 0. The only way that happens is if one of these two numbers is 0. Well, I'm looking here, and oh crap. The answer is 10, but we'll get there. I'm looking here, and so I see the answer is going to be 23 over 2, but that doesn't make sense. Then over here I get an answer of negative 10. That really doesn't make sense, but I must have set up my problem wrong. Anyways, so I'm wondering if this has to be plus, because then this would be negative, this would be positive, and this would be a negative answer, and a negative answer doesn't make sense. So then I'd have my positive here. So essentially, the big thing is factoring it appropriately, writing the right equation. That's obviously the important thing. And then realizing that one of your two quadratic roots cannot make sense, so you throw it out. All right, next problem. What is the perimeter of a right triangle whose hypotenuse? Oh, great. Finally, an AA Pythagorean theorem problem. So we have 65, one leg is 25, and we know this is a right triangle. And right now, you should be thinking, this must be a Pythagorean triple. And the most likely Pythagorean triples are 3, 4, 5, 5, 12, 13, 8, 15, 17. And so looking here, looking at the smallest side length, obviously these are the hypotenuse values here. The only ones that have a factor of 25 is this one. So therefore, this really, really must be a 5, 12, 13 triangle. At least that's what I'm hoping, right? And so 25 times 5, or 5 times 5 is this. So then 65 divided by 5 is going to be 13. Therefore, this is 12 times my scale factor of 5. So therefore, my side length is 60. All right. Find the area of a right triangle whose hypotenuse is 4 root 2. And, well, okay, we know that this is a 45 right triangle. Therefore, it's going to be 4 times 4, which is 16, divided by 2, which is 8. Find the length of the third side of a right triangle, whose hypotenuse is 12, and the other leg is 8. Express your answer in simple radical form. So this one, as soon as we see this, we know we actually have to use the Pythagorean theorem. So we have a squared, we'll call this a, plus 64 is equal to, and I did 8 squared, 144, which is 12 squared. So a squared is equal to, well, that's funny, it's 8. So that's 80, right? So square root. So a is equal to, well, I break this apart, so I know 4 and 20, but 4 and 20, so 16 goes into that, right? Yeah. So we have the square root of 16 times the square root of, how many times does 16 go into that? Well, so 80 divided by 16 is 5. Yep, 5. And so the square root of 16 is 4 times root 5. There it is in the simplest radical form. All right. 48 meters of wire furniture used to line a rectangular shaped lot. What is the maximum area that can be enclosed? So you know that, especially in 8th grade math, you know that the closer you come to a square, the larger the area. And as Tacola has been trying to point out for 3 periods, if we were able to make a circle, we get an even larger area with the same amount of fencing. Well, so we have 48 meters divided by 4, so 48 divided by 4. Why? Because there are 4 sides in a rectangle. So we get 1, 2, so 12 times 12 is 144. That's a square. All right, 4 congruent rectangles can be aligned to form a square. Here's my square. I mean, I know it almost looks like a square. So we know that if this is x, this is 4x. Because 4 of these short sides equal the long side because it is a square. And the perimeter of one rectangle, of one of the rectangles, is 30 units. So that means that's 4, that's 8. So 10x is equal to 30, therefore my x value is 3. So that means that the square that I have just made is going to be 12 by 12. And we want to know if the perimeter of one of these rectangles, so what is the units per square, so 12 times 12 times is 48. An equilateral triangle, the last three, an equilateral triangle and a regular hexagon share a common side. The perimeter of the triangle is 40. What is the perimeter of the hexagon? Oh, that's kind of fun. It almost looks like it works. The perimeter of the triangle is 40, and it's equilateral, so I know that. And it's a regular hexagon. So all these side lengths are the same. Great. So the perimeter of the triangle is 40. Well, the hexagon is going to have a perimeter that is twice as big as the triangle, because they all have the same sides. So it would just be 80. I mean, I can go further and prove it, because I could go 40 divided by 3. Well, that is 3.3 repeating times 6, and that would be 80. And I'll pull this up here. Hey, look at that. All right, find the area of a trapezoid whose, okay, so here's a trapezoid. I'm going to take an identical trapezoid. I'm going to color it red. Why? Because I want to. And I'm going to rotate it. And I'm going to place it right here. And look, I have a parallelogram. And the area of a parallelogram is equal to base times height. Well, I don't want the parallelogram's area, I just want the trapezoid. And so the trapezoid is half of that. But the base is made up of my two bases added together. So therefore, the area of a trapezoid is equal to base 1 plus base 2 times the height divided by 2, because I only want half of it, I don't want that part. So we have 5 and 8. 5 plus 8 is 13. So we have 13 times 6 divided by 2. So that's 3. 3 times 13 is 39. All right, last problem on this page. An isosceles trapezoid has parallel bases 13 and 25. All right, what is the perimeter of the trapezoid? And the perimeter, okay, if the perimeter is 58, what is the area of the trapezoid? All right. So a regular trapezoid means that you can do this. You can't normally do that, okay? Don't even try. So if this is 13, this is also 13, and so I have 25 minus my 13, which means that this has to be 6 and this has to be 6. All right, so then we have a perimeter of 58. So therefore, we have 58 minus my two bases, which are going to be, I'm going to add this way. So that's 8, and that's 3, right? So I subtract, I get 20 divided by 2, because I have 2 of them, I get 10 and 10. Oh, this is a, remember my Pythagorean triples? This is a 3 times 4 times 5 right triangle. Here's my 3, here's my 5, here's my 4. But I am multiplying it by a scale factor of 2. So it's a 6 by 8 by 10. So this is 8. And so now I can easily find the area. So I can safely say 38, because that's the sum of my two bases, times the height, which is 8, and divided by 2. I'm going to divide these by 2 here, and I'm going to get 19. So I get 8 times 19. So 8 times 20, that'd be easier. 8 times 20 is going to be 160 minus the 8 that I don't have, because that's right. And I get 152. All right.